So last time we had this alternate world generator. Maybe I can just abbreviate it this time as AWG, alternate world generator. And we have let's say an input side. Get this out of the way here. We have an input side and an output side. And on the input side we get information from, let's say, a tracker. Let's say maybe just a head tracker. Head tracker. If I can make that go into this AWG. Maybe a game controller. Doesn't matter what in particular I'm putting in here. I just want to give you kind of a high level view of the system. Keyboard. Maybe I can put a hand tracker in, whatever else. So there's information going into this. The alternate world generator has to use this information to make some kind of updates to the renderers. So for output, let's see, there could be a let me write it first. Visual renderer and then eventually this goes out to a visual display, and we talked about different examples of that. And it doesn't really matter which sense, so we can have another one that's an audio renderer. Audio renderer. And we get an audio display. And I want this to continue onward for other senses. So if you want to have a haptic renderer, you can have a haptic display that gives you force feedback if you like, right. So the job of the alternate world generator is to maintain this kind of fictitious or remote or recorded, whatever kind of world it is. It has to kind of maintain a lot of the physics of that world, a lot of the geometry and physics of that world in such a way so that you can output to these renderers, which then output to the displays, which then output to your sense organs, which then fool your brain, right. So that's the idea. So we have to figure out what goes into this alternate world generator. That's the main part of the software challenge here. So here's another way to look at it. If we add a little bit of geometry, I can say imagine we're superimposing alternate and not really sure what to call the world that you're actually in. So the alternate world and the local world, maybe I'll say local real world. Kind of emphasizing local. The non-alternate world. All right. So think about superimposing these. So somehow there's an alternate world that's being generated by the alternate world generator. I want this to be really geometry here. So there's an alternate world, and in this world there are, you know, maybe furniture around, pieces of furniture around, obstacles of some kind. Right. So there's stuff in the world, in this alternate world, and then this kind of story is being maintained that's fooling your brain that you're being placed into this world. So somewhere you appear in this world, so you maybe have your own kind of region where you're able to move around. So your head has been transformed into this world, embedded into this alternate world. So your head is here, and you have your eyes looking out in some direction here. They're kind of like virtual cameras looking out. And as you take your head here and move around, there should be a kind of perfect correspondence. You're moving around inside of here. This yellow zone is where there's a kind of superposition or overlay between the local real world and this alternate world or kind of virtual world that you may be constructing. Could be virtual, could be real, but it's the alternate world. So there should be a kind of overlay here between the two, and there's interesting things happen if, for example, you're moving your head and all of a sudden maybe this is one of the obstacles here. This should be a top-down view. So all of a sudden there's an obstacle in the world, some big piece of furniture or wall, and you decide to move your head into it. What should happen? If you have haptic feedback, it could smack you on the head, right? If you don't, what's supposed to happen? It's a difficult problem. So you have to figure these things out, right? Or maybe you just want to grab onto the controller and move your character around, move your virtual self around. If you do that, what happens when you come to these? You need collision detection. You need something that will tell you, no, you can't go that way. Or maybe you want to move right through it. That's the physics of this alternate world. You have to decide on what the physics of this world is going to be based on your task and based on things like comfort. It might not be very comfortable to just start passing through walls all of a sudden, or it may not be comfortable to just have your virtual self abruptly stop in the virtual world because there's a wall. That may not be comfortable. It's difficult problems, and I'll help you to understand why that is as we go along. In fact, I started talking about motion. So imagine this yellow rectangle. That's like your zone. In the virtual reality system, you may be sitting down in a chair. You have the headset on. You can move around like this, right? If you're on a rotating chair, you could rotate around. So you're moving around inside the virtual world. But in the physical world, you're also moving around. That's this yellow zone here. And maybe you cannot leave the yellow zone in the physical world. If you can, then you have a larger superposition problem, right? Maybe you're in an enormous region in the physical world and you can walk around in there with a headset on. You're being tracked. That's fine. You have to deal with, again, this whole problem of if you can really walk around, so this yellow region is larger, then you could interact with all kinds of obstacles. It ends up being an interesting challenge, right? Maybe a better experience overall, but you have more challenges. So I want to talk about different kinds of self-motions, and then we'll get on to the sensation and perception part, which is the final part of the bird's eye view. So self-motion is a very important concept in virtual reality. We call it ego motion or self-motion. So there are two kinds of self-motion. One, the user moves and the motion is matched. In the alternate world. Right? So if I turn my head in the real world, in this alternate world, I'm also turning my virtual head, and the two should match perfectly, right? If you do that all with zero latency, there's no delays, everything's very accurate, everything's optically done correctly, audio's done correctly, if all those things are done perfectly, that should be very comfortable and very convincing to your brain. The other motion is not. Through an interface, an example would be a game controller. The user locomotes or moves its virtual self. So in this case, you're not moving in the physical world, you're just grabbing onto a controller and maybe moving a joystick, so a little bit of motion, but then you're moving your virtual body through space perhaps very quickly. So this case you can see is quite different, right? So that means you're doing it all artificially. It's not a perfect correspondence. That would correspond in this picture to moving the rectangle around using a controller. But you've convinced your brain that you're actually there. So that means you're convincing your brain that you're actually accelerating, moving along at different velocities. And that's where the discomfort part comes from, and that's where simulator sickness starts to get really bad. So, to distinguish between the two, if you do faithful reproduction of the motions, perfect in the local real world and match that to the alternate world, you get the number 1 case here, which is considered generally very comfortable. And if you do the other case where you grab onto a controller and move, then it can be quite uncomfortable. And there's a lot of interesting research in how to make it comfortable, because you'd like to be able to sit in a chair and travel over long distances in virtual reality rather than having to walk there, right. So, so there's a lot of motivation, but it does cause sickness in many cases if you don't do it well, and it's very difficult, almost impossible to solve in many cases, to make it completely comfortable. So that's one of the things that people are struggling with. So case number 1, to summarize, that's where the head is moving inside of this box, and case number 2 is when you're moving the entire box, right, inside of this alternate world. Questions about that? Some examples of alternate world generators. Game engines are the number 1 example that people are using, right. So we're going to use one game engine in the lab, Unity 3D. Unreal Engine is another one. So game engines, great. There's other possibilities. You can make your own game engine, and what if we're our own simulator, right. You can make your own alternate world generator as just a kind of simple simulation environment. Right? You may want to hack it up in Python, for example. You know, you don't have to do something that's as complete as a game engine. And also keep in mind that if you choose to use a game engine for virtual reality, you're abusing the game engine. The game engine was designed to make games on screens, and there are virtual reality integrations of those, but fundamentally it took many, many years to develop game engines, a lot of trial and error, and now they're just being adapted to VR. They weren't optimized for VR. On a screen you can do this number 2 motion very easily and nobody complains too much, but in virtual reality people are complaining a lot. So it wasn't designed for that. The entire experiences need to be redesigned. What we would like to have is not a game engine, but a VR engine, a virtual reality engine. I don't think anybody knows what that's going to look like yet, but that's what's really needed. And if we have a virtual reality engine that can support the kinds of things we want to do over and over again in virtual reality experiences, we'll be in very good shape. For the time being, we're just leveraging the existence of game engines to make the software easy. So the game engine is this AWG I talked about, the alternate world generator. If you have a robot with a camera and you want to do telepresence, then you don't have exactly the situation, do you? You don't need a game engine. What you need is some way to maintain a panoramic representation while you're out moving around. So that's different. It's not going to be a game engine. You probably want to hack something special for it. So there are a lot of different possibilities, and you should really think about when you need to start from scratch or when it's best to just use a game engine. Since this is a 2-week course, we'll just use a game engine and make it easy. But if you want to, for your project, use something much more lower level and optimize it all yourself, then I would say go for it, you know, and get the experience.